guys. Good evening. I trust you had a wonderful day. And basically, this whole session is more like a run through of bash script. So I'll be going from the very basics to onboard as many people who have not who are writing bash script for the first time or who have just got into writing bash scripts. And we'll also look at things like best practices, why things are certain ways. So even if you could go on say like a blog post and say like a technical uh, platform and see what they are doing there and they're trying to explain to you why certain things are the way they are, that should not come as a surprise to you. So that's what this session is kind of for. And so basically, we'll just shell scripting is more of um, you know um, is more is basically the it's basically run on Linux. So we are going to start from trying to understand a little bit of Linux before we move forward. So that's like the idea. So I'll be sharing my screen right about now. So that's it. So let me just kind of, if you can see my screen, give a thumbs up. If you can see my screen, give a thumbs up, please. Okay, thank you. I don't know. Let me increase a bit. So the idea of shell scripting comes from trying to manage, configure, and provision things in a way. So if I was to get an environment ready, for instance, I'm trying to get an environment ready. There are chances that due to human error, I may leave out some things. If I'm to provision, say 100 servers, for instance, or I am to monitor 100 servers, how am I going to do this efficiently without having to look like I am doing the same thing over and over again? And it becomes monotonous from that standpoint. So that's the idea of shell script. And shell scripts are a collection. Every shell script are a collection of your everyday Linux commands. Every Linux command, even though some you use some more often than not, I'm going to say use the word every day in this context to mean that Linux command I already know. So it's nothing different. It's nothing unattackable. And let's just get started. For those who are not familiar yet, so on your Linux machine, you don't have typically do not have the GUI, like what we call the user interface, like how you see have on your Windows. Everything is operated on via terminal. But the cool thing about it is they are much faster using the terminal than the GUI. So if you were to check, for instance, where am I currently, you have done so many things and you don't know where you are at. So you could just press PWD, which means present working directory, and it shows that I am in the home directory of the business region. So that's the idea. So I'm going to be running over them and going back and forth just because we have like a lot of things to do. I'm trying to squeeze a lot of things into this class. So firstly, every shell script starts with what we call shebang. Let me write it down. Shebang. What is called. Every Linux command starts with that shebang. So if you have to write let's create a directory for this whole class first. So make directory. Let's call this bash. Let's just call it scripting. Scripting. Then we change directory into this one we just created into the directory we just created. Scripting. And we are there now. So if you're going to use ls it means to list files. If you're going to use ls is going to show me what if I have things there or not. But from here, we do not have things yet. So we can start and say, let's create something. Let's just say first search, first script. Let's call it first script. Dot. So this is how I'm going to call it. First script dot sh. Every shell script ends with the extension sh, and for obvious reasons, it's a shell script. And if we are going to go into it now, say and first, we have it's a totally new file. We don't. It's expecting us to write whatever is written into it to be a shell script because of the extension you are seeing just at the end here. So here's what we call the shebang. Here's what they call the shebang. So sometimes, even though you are tempted to use bin for the pound high, exclamation mark / bin / bash, you can't see my screen, or is it too small? Is that what you're trying to mean? You can't see my screen. I'm seeing like people saying you can't see my screen. Is it the same for everyone? Is it the same for everybody, please? Okay, okay. Everyone can see the screen. So cool. So let me see if I can expand a bit. So it's big enough. I think this is should be clearer. Is it cool this way? Can you see it now? Okay, cool. So there is no way you can change display settings. I'm on the monitor, so this is going to get as big as it can get. So guys, this is what they call the shebang. I told you earlier. It starts with the pound, exclamation mark / bin, and / bash. So basically, what is this trying to tell us that okay, bash is the shell we are working on, and bin is basically the binary. So we're going to check. It's going to check the binary in the bash folder, in the bash directory, just to show that oh, this is where we can execute the shell. And most times you have different shells. So if you have to go back now and look, there are several shells. There's the sh shell, there's the dash shell, there's the z shell, there's fish, and a couple other shells. But the most, I think the most widely used is bash, which we are currently on. How do you know the one you're currently on? You could check like this and see, let me see, shell. It tells you bin bash. So it is this one exactly you use exactly to start your shell script. But note that you are going to, if you're going to watch a lot of videos, a lot of people start their videos like their shell script like this, bin and sh, and it's still going to work. But that's like a terrible thing to do. I'm going to explain why. So we all have Linux have different flavors of Linux, and sometimes even though you might write this in the script, it's cool. It's the bash script. It's going to run on bash environment. But if you send to someone, it may work differently. Who knows? Because why? In some systems, when you use the / shebang, it is linked. It is linked by default to what they call the dash. So let me put that again. To what they call dash. Dash is, like I told you, dash is another form of shell, and bash and dash are very, very different. So bash and dash are very, very different. So if you are going to be using .sh, you cannot predict the outcome or the output of what you're going to be writing. So that's like a very terrible thing to do. So just write out, bin bin .bash. So it looks for it. So because in some environments, if you use sh, it's going to reroute you and link you to the dash environment, and everything you have written so far is not going to work as intended. So That's like the first one. So in shell scripting, the first thing we are going to do is to like write an hello world, basically. Let's just write hello world. And so the print, or if you have written Python before, print is to like print to the standard output what you want to see. But the Linux version of it, or the shell script version, is echo. So you can see echo bash scripting class, and it's going to echo it. It says bash scripting class. That's it. And you could echo as anything you want to echo as well. And you could want to say something like echo. Let me see. So if you remember vividly, when we ask which shell, it told us this. Yes. Sometimes it's what they call the environment variables. The environment variables. You can go on your Linux machine and try write env, and it's going to display to you a lot of things. So if you see shell is an environment variable, this is it. A whole lot of environment variables here. The name, pwd is there. What's it called again? So if you run pwd, that's going to show us this is where I am at home Gideon scripting. This is the log name, the home, and all that stuff. There's some tons of stuff here. So, and you should understand one thing, that the environment variables differ from PC from server to server, because sometimes you may have the most basic. The servers will be provisioned in needing the most basic things with no additional flavors. So in this case, this is like a WSL environment, Ubuntu Linux server, but it's using the WSL extension. So it's basically like an hypervisor built on Windows 11, and that's how it is. So that's like a difference. That's how you have like a whole lot of environment variables that we may not see in a like fresh, smooth, flavorless Linux environment. So that's like the idea. So if you're going to write things like pwd, ls, let's see again, and make directory and all that stuff, all these individual Linux, Linux commands, they make all the shell script. So let's go back to writing a shell script. So nvim first shell script. So what do we want to write now? We have no. Let's say every single time it asks us, let's just say hello user, echo, it echoes hello. Let's see if there's user. The user variable is defined. It says hello user. So if we could say, oh, the script runs every time it says hello user. But how do we run the script? This is another thing that comes into play. Now, please pay attention for those who are not familiar with this already. So there are two ways to run the script. You could say bash and first script, or which is more important, or which is usually the best way to run it, because you can't be running bash and first script all the time. So you could say first script. It's not working. So even if you write first underscore script.sh, it's not going to work because permission denied. Bash, this first script.sh does not have the permissions in there to run this way. So how do you know this? First of all, even though if you use the ls command, it's not going to show you the permissions it has. So you're going to use the long listing format with the L flag. How do you know all these things? So let me just, so you don't get it twisted. So if you write the manual page of the command ls, it's going to show you how to use the ls command, and for every other command going forward. So if there's a command in Linux environment, it most likely has a manual page. So you can come here and look through all the description and read what it does. Oh, ls this directory content. Oh, that's cool. If you use an A flag, it says do not ignore entry starting with the full stop or hidden files. If you use the author, it says, or with the L, it prints the author of each file, all that stuff. If you use the print only, list directories themselves and not their content. So that's like, that's like it. So if I were to LSL now, I'm going to see, this is it now. This is where you understand the permissions here. So in Linux, there's what they call the list privilege. Like, you give only the list privilege to everything. So if someone does not need the privilege, or if a user does not need a certain privilege, if a user is not using a certain privilege, I think and I know that you should not give it to them, and that's how Linux works. So if someone, so take for instance, you have a friend or an acquaintance rather, and he comes to visit you, say once in a while, would you just give them the key to your house because they come to your house often? No, that's not the idea. You give them the least privilege. So they could even call you sometimes and say that, oh, I'm not at home, but actually at home, and you don't just want to see anybody. But there are some people who you could give your keys to, even if you're at home or not. They come into your house and stay however they like. So that's like the idea, the least privilege. So if you come here, there are three, let me just explain everything. This is the first, hyphen here is a special, and that's why the special character. So it indicates the type of file that we are that are in that directory. So here it is empty. If you look here, it is empty. So that means it's a normal file. It's not a directory. If it's a directory, that means a folder, you're going to see D here. If it's a link, you're going to see L. And if it's a block, you're going to see B, all that stuff. So that's like the idea. So it's basically showing you the type of file that you are looking at. Then the first three, now note, the first, these are in three. They are in three. 1, 2, 3, 1, 2, 3, and 1, 2, 3. The first three, they indicate the permission of the user who's currently logged in, or the person who created the file. So who created the file? You're going to see Gideon. The person who created the file is in group, is in the is the user Gideon in the group Gideon. And I'm going to explain it why the group is Gideon as well. So when you create a user on a Linux server, it automatically creates a group as well of the user's name. That's the idea. So if I were to create a user called Akintunero, automatically I'm going to get a group called Akintunero, and the user Akintunero is going to belong to the group Akintunero. So that makes sense. So, and that is the default group of the user Akintunero. I don't know if I'm following, if you guys are following. If you are following, please leave a thumbs up. If you understand so far, leave a thumbs up. Okay, me. Okay, cool. Some people are raising their hands. What's the issue? Let me see. What's the issue? So what don't you get? What don't you get? What don't you get exactly?
G, don't worry, go ahead. Maybe
maybe
the reactions, they probably are not familiar with the reactions, like someone said.
Please,
can you take it from the LS?
Give them something like, some people to ask questions once in a while.
Yes, so anyone that wants to ask a question can just raise up their hand. They can raise their hands. I mean, and also that's why I was of the opinion that they checked the repo we shared earlier on, so they could easily familiarize themselves for the class. But I mean, it's fine.
You guys' message.
So anyone that wants to speak should raise their hand. So I can.
You can't see anything at all. My screen is still display. I am trying to get everyone along as much as possible. I'm trying to get everybody along. So let's see. Hopefully. So I think nobody has asked any questions so far. If you have a question, drop it in the chat. If you have a question, please drop it in the chat.
Okay, so someone said, please, can you retake from the LS? I'm not sure what that means.
If you have a question, please drop in the chat. Can I take it? You guys not having a question anyway. So, as we were saying, when you create like a new user, by default, it also creates a group of the user's name, and that person, because it's the same user, same name, created at the same time, that person, the user, automatically belongs to the group you just created. And here, This is a byte. How many bytes? This is like the size of the file. October 2. This is the time of last modification, not the time it was created anyway. Last modification. So you guys should get that. And this is the name of the file. So the first three indicates the permissions of the owner of the file. The second three indicates the permission of the group the owner belongs to. So if in this case, this is the Gideon group. If there are other users that belongs to the user Gideon group, they can only get this permission. So you can only read it. And the last group is others. So what I'm trying to say is this. So the first three is RWX. So and the first guy is the user, second guy is the group, second one others. So what I'm saying is, what I was trying to explain, this is what it looks like if everything was cool. So these first three permissions are for the user. It's for the user. The second three permission for the group, and the last three permissions for others. So if you're going to look at it from this angle, what does this mean? This R means read, W means write, X means execute, or that sort of thing. So if you're going to look at it, it means that the user does not have permissions to execute the file. The group has only the permissions to read the file, and every other person has the permission not to just read. They cannot read, write to it, they can execute. That means they cannot change the content of the file. Only the person who created this can change the content of the file. But you should note that as well, you can change any of these things because you are the owner who created the file. You can give them permissions to write or to execute it as what they like. So it all depends on you. So in this case, we are going to just be making it executable for just the user. So if I had to come here now, how do I make it executable for just the user? So use change modification, chmod, the user, make it executable for the user, and the name of the file. So you have made it executable. And if you notice, when we listed it using the long list for command, what did you see? This is the color, yes? So when you come here and do something like this, its colors are changed to green. So Linux helps you, distinguish which ones are executable or not without having to look here. So if you see here right now, yes, the executable, is the placeholder for that here, X, after making it executable, and the others stay the same. So if you're going to execute now, you're going to see something like a full stop / and execute. So now, if you notice, if you go back to the script, it says echo hello user. Why does this not give us something like, why does this not print out something like hello user? Why does it not print out something back to us? It does not print because I was trying to tell you guys earlier, it is an environmental variable. And if you're going to do something like this echo user in this case, it's going to see Gideon. I can change it and it's going to give us something else. So let's see what's going to happen. So let's export say class is equal to WebEx, or you come here like this. If we echo class, for instance, it's going to give us WebEx. So that's the idea. So yes, for the person asking, you can also change it with numbers as well. For that's it's quite simple. So I'm going to go over it again, but not now. But let's just get it started. Let's just get out of here first of all. So this is how you get environmental variables. But the thing about it is that what I just did now, this environmental variable I just created now, it does not persist. That means if I log out and come in again, it's only for this session. It's not going to work again. So that's like a cool thing. The other ways to make it persist, I'm going to talk about that. And in some cases, there's what they call just because using the shell scripting is all about automation and getting things done faster. And you could get things done faster even without using the shell script. And here's what I mean. So sometimes you can type clear and it clears everything. That's like the command to clear stuff from a terminal. You could also do something like this, alias CL is equals to clear, and it comes here. So even if I type CL, it clears. So that's something as well. And I'm going to be like talking about this. So don't worry too much. So I'm going back new Vim and our first script. So now that we have been able to get this done for our first script, where do we go from here? We can do something like this. What if the person entering, we don't know who's entering? Let's say it's over like a normal environment, like we don't know what's entering, and we want the person to better enter their name. Let's say something like, say, I don't know the person's name, so let's see. We want to take user input. Let's just talk about that. Even though I think it may be too soon, but let's talk about that. So we can say read. Let's try to read what users input. So we could say ROP. I'm going to talk about that recently. So you guys hold on. ROP. We'll talk about, or we'll say something like, please enter your name. And you're going to say something like this. And enter what we're going to call this. We're going to call this name. And we're going to do something again. And say, rate. Let's try it again. Rate. Which class? What? I think it's from your end. These guys, I think if you can hear me, please give a thumbs up. Because my internet is pretty cool. Please give a thumbs up if you can hear me clearly. So I think a lot of you guys can hear me clearly. So it's just you guys. So you don't talk at my attention too much. I don't think it's me. So what class? What class? Oh, what's your specialty? What's your specialty? Then you answer, and it says specialty. You come here and say echo and say something like hello name. I see that you are a specialty specialist. Cool. So if this is you, for instance, let's just say this is you. You are right. You want to let's see how this is going to work out for us. So let's just say this is you, for instance. You want to see it. So before someone's asking what's read, we come here. We're going to look at read. Man, read. So read from the channel. So that's the idea. What read does. So you could go down and read a lot of these things, but if you are going to, it's not going to give you the accurate descriptions as much as I want. But arrow means, if you noticed, I cut it. Yeah. So arrow means is to make it P is to make it a prompt. P is to make it a prompt. R is to ensure that if you enter things like wildcards, what are wildcards? Asterisk, backslash, all that stuff. They are wildcards. So if you enter wildcards, it's going to take it as a string. That's it. So the arrow ensures that things that are wildcards that could easily pause your what's it called now? That could easily pause your script. It does not take that as a string and not as a command. Then P takes that as a prompt. So if I were to run this, here's what I'm trying to say: prompt. Let's run it now. It's going to ask me a question. What's my name? And let's say my name is JJ. What's my specialty? Cyber security. So if you're going to look at it, you say, hello JJ, I see that you're a cyber security specialist. Cool. So that's that's some of the things that you could start doing with shell script. It's not so hard, but we're going to get into details later. So one of the first things we are going to look at is how we could get around. Let me just open the this thing here on my PC. Let me open the let me see. Pull it out. So hopefully. let me open the repository. The ones that the Linux repository. So let's go through it. Let me go through it and let's see how I can pick the individual things here and we'll just get started. So on this 30 days of bash. And let's see the first one. A lot of them may be advanced and too soon for us to code it. So we've talked about the basic commands and navigation, how to get out, so how to get into folders or into directories, but we're not talking about to get out. I don't know if everyone knows how to get out. So we're going to talk about that. That's one end. We are going to look at loops, if we can, functions maybe, and we're going to understand how to read shell scripts as well. So this is something we just looked at now, how to make it, how to make it cool, interactive, prompt, using prompt. This is in case you are not going to be, some things are better left for you to enter than for you to hard code them. And other times you are going to run it on a server, for instance, on a remote server, and you would not be able to enter it as well. You could instead define them as environmental variables, and it just calls them as environmental variables or something like that. So the environment you are determines the kind of approach you're going to use in your shell scripts. So let's go. Let's move forward and let's see how we could do a lot of things with this bash script. I'm not going to be looking at this. Let's go forward. So still in the first script. So let's create a small script. Let's what we're going to do. So this was a cool thing I came across. They said, I think, I don't know if I don't know how can I share that, but I'm going to share it in the chat. So you can go to HackerRank and look at some cool bash script stuff. But here's what it was. It says, how do I know something is isosceles, an isosceles triangle, a scaling triangle, or an equilateral triangle? So let's define that first of all, so we get an idea. So isosceles has two sides equal. So an equilateral has three sides equal. And say scaling has no sides equal. So my spelling. So here's the idea. It says, how do we, if for instance now we were trying to create like a script that checks for the equality of triangles. We could just enter any triangle, enter the names of the sides of the triangle and see if it's going to work out. How do we go about writing it? So we could do this in so many ways. So let's just call it triangle checker. There are two, like I said, there are two ways to create like files. Either you use touch, or you could just enter the name of the editor and name of your script, and it just works out like that. So let's see. But this one is not this one is not for automation. Using touch is better ways for automation. We're going to get into that much later. So let's see. Triangle dot sh. So we are going to start with the cool thing we always do. Start with the shebang. So you should remember that this thing here is based on your Linux environment. So what do we do? Let's check. How do we check if two sides are equal? Two sides are equal. So remember, we are going to be doing a lot of logic here. So we are going to ask the program to check if all three sides are equal. First of all, if all three sides are equal, cool. We're going to say it is equilateral triangle. So let's say something like, if all three sides are equal, how do we check for equality? Equality is typically let me just open it. If all three sides are equal. So if side x is equal to side y. And because it is a must for all sides to be equal, if you are going to be using all, it means one of them can be equal. But if you're using and, it means all of them can be equal. You have to check if all sides are equal. You are testing for it. So if you are testing for something, in some environment, you're going to see one square bracket, but always ensure to use two square brackets because that's like the model rule. It will run, but then again, for consistency purposes, you should also have, if you're using VS Code, you should try to install the bash checker as well. I don't have forgotten um, the extension, but you should just do well to check that as well. So you could say, let's check and see y. So what's y going to be equal to now? Y is equal to z. So do we have to check for if x equal to z? Do we have to check? So we don't have to check. And here's the reason why. If x is equal to y, automatically x and y are the same. Then if y is equal to z, it means x, y, and z are the same thing. So that's the idea. So using this and means what? Both of these conditions have to be true. That's what this and means. If this and this are true, that's the idea. If this and this are true. Now, don't make the mistake of using one equal sign. Always use two equal sign. Two equal sign is to compare. One equal sign is to assign. And by assign, I mean to assign like a variable to all that stuff. So if you use one equal sign, you're going to be shooting yourself in the foot, and you're going to get all sorts of errors. And we'll just show you something similar. So we could just go to the end and say, okay, cool. We have checked if this is equal to do. Then what should you do? I want you to shout that it's an equilateral triangle. Equilateral triangle. Then we could come here as well. Else if because we are going to be, what's the word now? We are going to be checking for multiple scenarios. That's why I'm not using else. If you're using else, it means that's after else, that's the end of it all. But elif means after this, we have to check multiple conditions in this case. So we are going to see now. Else if, let's say, else if we are saying, if any two sides are equal, any two sides. How do we check for any two sides? That means we are going to compare x and y. We are going to compare x and z. Then we are going to compare what? Y and z. That's the idea. But in this case, we're not going to be using the and, because we just need one condition to be true. We don't care which conditions are true. We just need one of the conditions to be true. So we use two brackets as usual and say $x. If side x and side y are equal to, then it should tell us if it is isosceles. But then again, what if side x and y are not equal? They're not the same. What if it's side y and side z? You could just come here and say, or this what if any of these conditions are not true? What if it's just x and z that are equals? This does not take into consideration that. So we have to take every single condition into consideration. So what if x and x is equal to, see, then we are going to come do it this way. Then what should they do? If else it should echo what? Isosceles. So then for our very last thing, we can say else if none of them are equal, do this. But in this case, if two of them are not equal, if three of them are not equal, it means none of them are equal. I don't know if that makes sense. If any two sides are not equal, or if all three sides are not equal, it means none of them are equal. So we don't need to add anything here, any conditions here. Else just tell us it is a scaling triangle. Just tell us it's a scaling triangle and move on. And for every To close out the if loop, you use fi. So you should note that for bash script, if you are going to be using the reverse, how to close out a loop or a switch statement or all that stuff, it's really reversed. So if you are using something like a case, for instance, you're going to be CASE. To close it out, ESEC. That's the idea. So all these things, all these variations are just like, a way to close it out. So if you're going to come here now, what are we checking? What are we checking, for instance? Let's come here and say, okay, let's check. Let's call x is equals to 2, y equals 3, z equals 4. Let's go and see if it's going to work. So what are we going to do this time? We are going to do the same thing we did the previous time, is to ensure that this is executable. And how do we execute it this time? The first time we used, we use this style to execute to chmod. Let me just show you how we did it. The user should be executed, make it executable for this user, and write the name of the script. This is how we make it executable the first time. But now let's use the numbers. So in shell script, you can use, there are two styles. So arrow.wx is equal to 7. And I will explain. R is equals to 4. The read permission is equals to 4. The write permissions is equal to 2. And the execute permissions is equal to what? Is equal to 1. So with this in mind, what is the permissions of this? So that means since we have just arrow w this space r space r space. If we are going to calculate this in this instance, that means 4 plus 2 is 6, yes? That means 6. Sorry. 6. R is 4. R is 4. So that is the numerical equivalence of these permissions. That's what it is basically. Numerical equivalence of these permissions. So if in the unlikely, if in this scenario now we want to make it executable, we don't want to change anything, we don't want to use the u plus x, we can say chmod. We want to leave the rest the same, the other part is the same. We just want to change this very first part. And x is 1. If we want to add x to this one now, is 7. So we're going to put 7, 4, 4. And we're going to open triangle. Voila. So if you're going to put ls, you see it's green now. Same style. So you can either use chmod 744 to just do that, or in the same vein, I can go and say I don't want any other person to look at it again. In the same vein, I can come here and say something like this: 700. What does 700 mean? 700 is going to mean that only the owner of the file can see or can read, write, and execute it. Every other person cannot even read it at all. So if you're going to go back now, you're going to come here and say, enter it now, come here. It says they don't even have access to it. They can't see anything here. So that's like the idea. We could play around with this thing and say, well, let's just call it 600. We're going to call it 600, or 2 plus 1, let's say 300. See, we cannot read it, but we can write to it. It doesn't even make sense. So, so let's go back to doing this, and we are going to see basically. So if you are going to cast the triangle, it means that you don't randomly assign numbers to it. Like I said, in the Linux environment, R is equal to 4. It is stipulated. It is not changeable. W is equal to 2. Sorry, and X is equal to 1. You are not changing. You're not the one that changes it. You don't assign values just randomly. So it's based on these numbers that you're going to change the permissions numerically. That's the idea. So as we see, we had coded X, Y, and Z 3, 3, 4. So 3, 4. That means in this case, if these two things should be isosceles, right? Because those two sides are equal. So if we're going to come here and say triangle, for instance, we could come here triangle and come do something like this. It's going to say isosceles. But we cannot test for other equilateral and scaling. So how do we do this? We could come here and say VI. Let's go now. Let's go. New thing. And triangle. Let's edit it now. Let's ensure that we can enter. If I want to change these numbers every time, I'll just come here and search in them just to test it. No, that's not that's going to be so monotonous. So instead, what we're going to do in this case, we are going to say do something even cooler and use the read as as expected RP and say enter side X. It should note that the only reason I am leaving this space is to make it look cool. If I didn't leave this, I'm just going to show you how it's going to look without the space. So if I'm going to go back now and do something like triangle. Sorry. It's so close. And if I enter, say 4, for instance, isosceles. If I enter something like 7, it's going to say scaling. But here's the thing. The other part, I cannot edit them as well. So I'm going to do the same for all of them. I just want to show you how it looks so close. X is equal to 4 and all that stuff. So we could just make it, so it's just for aesthetics purpose, nothing really. No, there is no cheat to it to say I have to list this all the time. And putting the X here means this is what I want to name the variable X. So I'm going to do the same thing for here. So I'm going for like so here. So RP. I explained what RP does. RP does, RP prevents any special characters from being seen as a command. And P ensures it comes out as a prompt. So it says enter side Y. And you go to enter side Y. Call it Y. And so we come here. So that is going to be as more graceful than before. So we're going to say triangle and enter. What side X are we going to enter? Let's just write any number 7, 8, 9. It comes scaling. Let's say 2, 2, 4. It comes isosceles. Let's put everything to. Let's put it now. 4, 4, 4. It's going to be equilateral. So I don't know if that makes sense. Does anybody have any questions of what we've done so far? You don't understand how this line you're trying to look at and you don't understand, just let me know, please. And if you get it, leave it thumbs up. If you don't, just leave a question, please. Let me check the charts. Where's the green? So I think everyone gets it. So that's like one of the cool things you can do with Word. So even better, you can use it to read scripts. You can use the read scripts, and I'll give you an example. I'm just going to show you one quick one. I'm going to show you a simple one and one an old one I wrote like some time ago, just so you could get like compare and contrast and see, let's see. Let me see if I can find that somewhere. It's nothing too complex, but it's just you trying to understand what it is. And you find it. So let's leave that for now. Let's say reading file, reading.sh. Sorry. Let's say reading.sh. Now, in this case, this is quite cool. I'm trying to show you how you could read files using, or how you could Would it be read in this case now? But as we go, it's going to get to my head, and the best thing I'm is going to get to my head soon. So let's see. Let's say we want to I'm trying to think of something we could do. Okay. Before we get there, let's just go somewhere else and let's see how we could do that. So let's go to functions. I'm going to change the name of it. So let's go to functions. How do we do functions? Functions is the same thing. No, we don't want to call things like repeatedly. So if you're going to write a long shell script, you don't want to call the same things repeatedly, or you could just put them to something and just. But let's go forward. For those who have written programming, I get the idea I'm trying to say. Let's say I want to check the free memory on my server, and you guys can use this as well. So it's something that you could see. So let's check for free memory. We want to check the free memory on my PC. So this is how to write it. You're going to use an opening and a closing parentheses, then opening curly brackets, and here. So how do we do this? So I want to make this as cool as possible. So you could say echo hello user. And there's one cool thing we do in Linux. Every single thing you are in charge of in terms of script writing. So delimiters as well, you are going to go in charge of it. So let's say echo, so it looks cool as well, and the space has space stuff. So let me count it. 1, 2, 3, 4, 5. Asterisk 1, 2, 3, 4, 5. Asterisk. Then come here and say echo again. And say something like, here is the output of the free memory you are asked for. Let's look at it that asked for, and we could open it as well and say voila, and enter the command free memory. This is how this command to check it, and we use our closing brackets. Then let's just come here, just script that outputs the that puts the free memory in running processes. So let's come here. So let's come here, just so we get an idea. So because because of the system processes, and open it in this case, close, same thing. So define it. So how same style. So echo. So we can shift. If you notice, if you have to call them together, there's not going to be difference between what we have here and what we have here. So we will want to give like the differences between this one and this one, like the first output and the second output. So that's why we'll be using this delimiter here as well. So it's nothing, you could leave it as well, but the idea is to ensure that the readability factor is also achieved. You could come here and echo this system processes. That's for so we could just use PS UX. So I'm here, same thing as well, closing brackets. And how do you call them? Simple, free, and system run. So you know that the idea, me trying to what's it called now? Me trying to give a space between them does not give a space between them. It doesn't. It's this thing here that gives a space. So we could go back and say, okay, let's check as well. So that's your script. You want to every single time, instead of just entering the normal commands, the normal thing, and you just want to say, oh, let me check these things. You could just append it over you. So you could say new theme. Sorry. Chmod user X reading this. So come here and say reading. So it tells me this. So if you notice, it says hello Gideon. It says here's the output I asked for. It can give me the output I asked for. Then if you notice the delimiter that we had to put in the former one, and it says the products that are currently running are this. So I don't know if this makes sense. Do you guys understand why I did here so far? It's just like a simple thing, just that we just made it. It's just two commands anyway. It's like grouping free M. It's like writing free M and say, let me see, PS AUX together. That's what the script just does. And it gave us something like this. So that is what shell scripting is. So it's like pitching, it's like draining two things that you thought we not have, like, doesn't have like a cool output or a cool use case, and it just makes a cool use case. So that's what shell scripting is. So come here now, you see, I ran both of them together. You see, it does not even show, you don't know where one starts, you don't know where one begins from if I run both together. But with that script, it says, hello Gideon, here's your output. It tells me this, and it tells me this. So even cooler, you can forward this thing to like you can make it run every single time, say every single morning, or every single morning you open your PC. How do I do? Let's say you have like a cool habit of waking up 8 a.m. and you do everything you want to do, and by 9 a.m. you have opened your PC, and you want to see that's the first thing you want to see. So let's see how we're going to do this. We use something they call a cron tab or cron job. So for you guys, that's with cron tab.l. So to automate it, so you can list all your cron tabs currently running on your PC. That's to list it. You most likely not see anything here, but I'm going to explain it for you. You most likely not see anything if you have never used it before. So it tells you, it explains to you every single thing here, and it says MHDOM like that. So basically, what does it say? M stands for minute, H stands for hour, date of month, or then month, day of the week, then the command. So 0 to 59, that's what the minutes, that's the values you can enter for the minute. Then for hours is the military time. So from say 1 to 23, 0 to 23. 0 to 23, that's it. So that's how you get to go. Day of the month, 1 to 31. So you could, in some cases it could tell you if it's it's not going to, if you obviously put 31 for say February, it's not going to work, that kind of thing. It's not 31st of February. So month 1 to 12, day of the week, you could say 0 to 6, 0 being Sunday, or but Monday is usually 1. You could call 1, 2, 3, 4, 5, 6. Sunday call it 0, or Sunday call it 7. So it all depends on you. Then the command you're going to enter. So here, if you notice, I already put things here. So that was when I was trying to show someone something. So 2621 here means what? By 9:20, 6, always echo hello world. Always echo hello world. Even though the time now is 9:05. If I'm to put it 9:07, echo hello world, we are not going to get it. And I'm going to show you why. Let's just get started. Let's say contact E. And come here 9, the minutes, let's put it in 6. Let's put it 6. Or no, 06. So it says installing new cron tab. This is 9:05 p.m. Let's wait for 9:06 p.m. So let's check the date. Still 9:05. And you should also understand something. If in your likely scenario that you have set up your cron tab, and your cron tab, if you're using your PC's, say your PC time, and your Linux and memory time is not the same, you should always endeavor to set the time. That's something you can always check for it. Check the time zones. It could differ. So let's check again. Date is 6, and we still did not get it. How we did not get it? So what happened? What happened? So if you're going to check for, say, check in the syslog, you're going to see cron prime. But why did not echo hello world? By default, the cron, the cron job, the cron processes does not output. So every output, every standard output that you already would need, it will not put it out there. But it worked. So instead, you would most likely want to redirect it somewhere. So let's see. Let's go back and edit this boy. The boy. So let's check the PWD right now. PWD. And it says home Gideon scripting. Then what do they call that thing here? We just did reading.sh. So let's see what's going to happen. Let's come here and put something here and delete everything. So what command we want to run? Say insert this and say reading.sh, reading.sh. So what time do we want to put it in? Say, let's say 908, no, 909, 909. And let's put it in this case. Let's put it in a home. There's no script, there's no, if you notice, sorry, home. Just home, okay. Let's call it log file or file.log. File.log. So what are we trying to do here? That he's going to run this command and push it somewhere here. If you should understand this thing here, that we are using one greater than symbol. If you use one greater than symbol, it's going to push it. So if you are going to do the same thing over and over again, you're going to find out that it's not going to show as much as you want it. Instead of that, it's going to replace the next thing that was there already before. So instead, you may want to use double sign, so it appends. So if there was something in that file before, it just appends. So let's leave here and let's see how this is going to work out. So you see, these are the only files here. So these are the only files here. So by 2109, we should have something here, hopefully, if everything works out well. So we should see, let's see, same time, date, and still work out. So in a couple of seconds, we should have something. Let's check date again. Cool stuff, cool. So let's see. It didn't work. Why didn't it work? Does anybody have an idea? Does anyone have an idea? Does anyone have an idea? Let me check the chat. No, we are in log file directory. If you notice, this is home, Gideon scripting file.log. So it should have that already. There's no file.log here. So why is it not working? Who has an idea? Let me check the chat. Directory is empty. The file permissions. So we already defined for file permissions. So what could be the idea? So you should understand something that sometimes you may have like a faulty cron, and regardless, you could have a faulty cron. One way of checking if you have a faulty cron is to enter the etc folder and that's a bring us to file systems. Let's kill the console, and that brings us to file systems. So you could have like you could just check them like ps ax and say, oh, this is grep. So for those of you who have not come across grep, what does grep do? So I'm trying to check the processing on my PC, for instance, on my server. Sorry, ps aux. Sorry, aux. There's a lot of things, and there are so many things running here. There's a VS Code server here. There's an processes, and there's a ps aux here running. So I'm going to explain this why it's going to be like this. So This is what grep does, PS AUX, and I'm trying to look for the PS AUX running. PS AUX running. So the reason I'm using the parentheses here, if I'm going to run this without the parentheses, it's going to take this as individual commands and give you something else. So when you run like this, it's going to show you just what you're looking for. You filtered out this. There's only one occurrence of PS AUX running. And this is not the second occurrence. What this one is the grep running. Just grep that's running. It just happens to is a grep that was looking for PS AUX that they put together. So always ensure that if they ask you how many processes are, it's something you could see like in an interview, and they're asking you how many say processes are running, and you have like a bunch of them. Most likely the last one here, the last one is not going to be the process that's running. It's going to be something else. So that's the idea. So let me see if you guys got that. So okay. So tab trying to fix this. So let's see what's going to happen if it works this time around. Because sometimes your WSL, if for those of you using WSL, your WSL can have tricky things like this. Like when you're trying to say system CTL. If you're going to use system CTL, it's not going to work. It's going to use system D. It's not like it on system D. So you have to use service. So usually you want to use system CTL, status cron, all that stuff. But on WSL, you have to use service. So that's something I think I should point out as well. And you could check the etc folder. etc folder. etc folder. Cron. List all everything related to cron. So sorry about that. So if you notice, I used a let's example, let's check the date. Time has passed. Dot zero. Yes, it ran now. So most likely my cron was having an issue. So if you check the file log now, cat file log is going to give you something like this. And I'm going to explain why it's going to give you something like this. And the reason why it's going to give something like this is because it will start thinking and come in and push this out. Come in, trying to expand this as much as possible for this thing looks clean. So for system processes, when you check your system processes, this is what it means. The user who runs the process, the PID, the process ID, the percentage of the CPU used, the percentage of the memory used, virtual space, RSS, then TTY is the terminal, then start. When did this start? Basically, October 1st. So I have not put off my Linux environment since yesterday. The time it has been on, then a command. So it just happens to show that, this up until here is a command. Same thing here. The mount is a command. Same thing here. So if I were to discontinue these things here that are running, the VS Code server, because I have something else open on VS Code, the VS Code server, then it will go to more readable. I don't know if this makes sense. So if the fact that you run it here, you see the things here, we are shortened. So this is not the end of the command per se. This is not the end of the command. So this is like the entire thing and because you are cutting it, you are pushing it to a file. It just happened to show you everything. So I don't know if that makes sense, guys. Do you understand, or you don't get it? Please ask questions in the chat section. Okay, Dimitri, you got it. Does anyone have questions there? Okay. I think everyone gets it. Directory is empty. So cool stuff. So if you notice, the directory was not hidden. Everything was cool. I just wanted you guys to see how cron can misbehave sometimes, especially when you put on since it's not like your AWS server or any other server. It's just your local machine. So it's something you may want to look at. That's one of the essence of this whole thing. It's about troubleshooting. So I typically thought my code is correct. It's ran cool. The time we put was correct. What I think was the gain. Cron was not running, so we had to check and start and run cron. So that's on that way to troubleshoot. So does that make sense? Do you guys want to see how we could use cron for something? So if in your likely scenario, in a scenario we want to write, say, every morning, I'm going to wake up every morning by 9 and put this here. So every morning by 9, I'm going to put it here and put asterisk here or put a 0 here. So every day by 9 p.m., by 9 a.m., if I write 9 here, it's 9 a.m., do this and send here. So that means I want to see every single time this script, just run it and put it here, push it here. It is going to run again. It's going to do the same thing because why? It's going to put add it beneath it. But if you use one greater than, it's going to clean everything that was in the file before and put something new. So that's the difference between appending and just straight redirecting. So I think that's one I wanted to point out. So we could also look at something from, say this angle. So let's see something now. I wrote something that was a while back that was a little bit advanced, and let's see. So so let's do something that does file counts in the current directory. Let's do something that does file counts in the current directory. And I'm going to show you something cool. There are scenarios. Sometimes using echo does not have to be echo is not just for prompting alone, or to prompt you to enter your username. So here's maybe a prompt triangle. This is a prompt. Enter side X. That's a prompt. Echo is not just for using or for read or to prompt you. Echo can be used for debugging. By debugging, I mean it's telling you what's going to happen next. So let's say listing message. So if you're using your Vim or anything, it's going to be this /bash. So let's do something now. We want to greet the user. Let's greet the guy who's now the environment. Let's say I'm trying to find a way. Name. So take notice, name 1. I'm trying to show you how to use arguments, how to take into arguments, because this is something you may be doing all the time. So what does $1 mean in arguments? So if you are going to open something new here. So this is the command, sorry. Cards Q. Okay, let's say this is the command. Let's say ls is the command. Anything that follows it like this is an argument, all that stuff. Anything that follows an argument. Or if this is a special script message. If I enter something, say Gideon is a command. And how does it know, how do you specify the commands? Let's say Gideon, Achen, Puma, JJ, right? Like a lot of the names here. So this is position 0. The script itself is position 0. Gideon is $1, $2, $3, $4. So this is how you count it. So if you notice here, so if I'm saying say $1, it means if you are running the script, you should accompany your name with it. If not, it's not going to run. But before we digress, let's just show how it works in full swing. Sorry. So $1. Let's see. So it says echo hello $1. Keep doing this every time. And the simple script, simple. So if Z means if 0, if this thing here, if this guy here. So in this case, this is a variable. The dollar name is a variable, and this $1 is a variable. But $1 is argument variable. It's taking in your argument. So if it says if the argument is 0, there's nothing inside the argument. And as I want you to write it, I'm trying to be as anti as possible. If there's not inside the argument, what should you do? What should you do? Say echo something like you did not enter your name, then it exits 1. Sorry. No, exit 1. This is the exit status, and you're going to start again. Else, you could say else and say, oh, we could say else, you could say echo, sorry. And we are going to call the function. And how do you call functions in this case? How do you call functions? You don't just say greet $1. If you say greet number $1, what are you doing? So let's explain the right content now. It takes in your argument and assigns to the something name. Excuse me, sorry. It assigns to let's say name, and we say hello. Let's say Gideon was the argument. Hello, Gideon. And it says, if nothing is in the first argument, then echo you did not enter your name. Let's even put that first of all. So for the first person who enters, just say echo. That would be too much. That's not going to work. So let's see. So greet this person. What is it going to say here? It's going to say greet Gideon. It's not going to say actually something like hello Gideon. It's going to say greet Gideon, because we have not called the function as it's actually called. How do we call the function? We use $, this, and this. So this is how to make it. So it says greet $1. So that's greet. Say hello this person here. Because if you do it without the dollar and the parentheses, it's going to say greet the first argument. But if you use the dollar and parentheses, it's going to use the function here and say hello, the first argument. So I don't know if that makes sense. And you are going to round up as usual with FI. I'm going to say something like, now let's count the files in the directory. So we can say file count. Let's call this into a variable. So how do we count a file? We count a file. You list out the file first of all using a long list command. Then there's something also. When you use pipe means the output of one command make it the input of another command. That's what pipe does. It takes out one output and puts out this. So let's say this as well. So WC, you count. But how do we make this? How do we make this file count read everything as 1? So here's how we make it. We use the same style again. First one here, second one here, and everything becomes easy. So we can say something like this: echo, there are, sorry, there are file count files here. There are file in in this directory. So this is it. This was going to tell you. So the idea of this one is to help you create something cool. So let's see, we are done here. The same time, chmod, let's say 744 to make it and call it listing. So now listing. I didn't put my name. He said you didn't enter your name, it just exits. For now, let me put say JJ. Listing JJ. He said, hello JJ, there are 6 directory files in this directory. We count them, we have 1, 2, 3, 4, 5. All other files are here because all other files are here. There are 6 files in the directory. Why is it in 6 files? Who has an idea? Why is it in 6 files? Anybody wants to try? I'm looking at the comment section. The hidden files, cool, but there really is no hidden file. It's not looking like magic to you. What part? What part is looking like magic to you? So let me answer. I think there are a couple of questions I didn't see because I was too busy. I'm looking. So let's see. Okay, hard coding means to just write x equals to 6. You cannot change it. You cannot really change it unless you have to enter into the script and change it. So that's what hard coding means. For Teams, if you are still here, that's what hard coding means. So you can use VI or Nano, anyone you want to use, but it all depends on you. You can even use VS Code. It all depends on you. But you are going to be in the scenario where we are going to be working in, say, with servers. You don't have the luxury of using any what do you call it, any server of your choice, any editor of your choice. You have to understand how to use all of them. So permissions, cool stuff. So yes, great to specify your search. Then from Contab uses your device, your Linux server, your Linux servers and time, not necessarily your device time. So if I'm using a Windows PC and my this thing here is not correct. So let's say date, for instance. This is the date right now, and I have to do time date CTL, CTL, and I'm trying to check time zones. Set time zones, time zone. And I put something like Africa, Accra. Oh, great. Why? Why is this guy doing like this? So let's see. Okay, time date. I'm trying to show you guys something. List time zones. Oh, the host is down. So we'd have to use something. So basically, for it could be different from your server. Time date CTL is what you typically would use to check for time zones and all that stuff. But it's here, but it's not running because the system was not booted with it as the init system. So just get heads up. That's some of the things you could see as well. So that's why you may want to use say VirtualBox to provision your own Linux server. That's it. So that's what the Contab will use. Contab is going to use the one on your server, not the one on your Windows machine. So if your Windows machine and your server have different times, that's going to be an issue for you. So what part is looking like magic, please? Okay. So let's see. They count 1, 2, 3, 4, 5. It's saying 6, not 5. It's saying 6, not 7. And it says there are 6 files in this directory. So that was asking, why is it saying, okay, you don't understand if Z is equal to 1. What he's saying is the if statement, cool stuff. The if statement is saying I'm trying to tell this thing what to do and what not to do. So the script will run cool if I write something like this list and write, say, the user's name, who is trying to use the script. Gideon is trying to use the script, or say David is trying to use the script. David, sorry. David's trying to use the script. And it's going to run like this. That's how the script works. If you don't add this first argument part, it's not going to work. So I want to ensure that the person knows what they should do when they run the script. So the if statement says, if this is empty, if the first argument portion is empty, then say you did not enter your name and exit with a what's it called? It's an error status. In programming, error status are 0 or 1. 0 means it runs cool. 1 means it did not it left an error. So that's like the idea. So I don't know if you should like try to understand that's something you may need to find out yourself as well. But that's how it is. So there is no why it's like this. So when you see exit 1, it means it's going to exit out of it. When you see 0, it means it's going to say still continue. So that's the idea. So else, if it's not empty, if it's empty, do this. What's the other option we have? That means it's not empty. If it's not empty, echo greet this person. Then you have finished with the if statement, the if block. Now, what does this guy do here? He counts this file ls, basically, same thing. Ls this, and you are grepping into WCL6. So you are grouping this thing here, putting it into this variable. You put this whole command as a variable. And you are saying echo Terra dash files in the directory. I don't know if you've gotten it now. I think that should sum it up right now. Okay, cool stuff. So does anybody have an idea why that did not work as intended? Does anybody want to give it a try? Because I'm listening. No, that's not it. We have the permissions. I am the user that created all the files here. So that's not it. So the reason why, so let me just I'm keep making this mistake, sorry. LS. Ah, God. So the reason why this is going to show 6 is because here, 1, 2, 3, 4, 5, 6. It is showing a summary line. I don't know if I'm making sense. So when you use ls, it gives you is ls l minus l. It gives you a summary line. So this summary line is what WCL counts as the 6th line. So it counts everything as files. So because it didn't count it as files, but because I put their dash files here, it's saying there are 1, 2, 3, 4, 5, 6 files here. So I don't know if you guys get their explanation. Do you get the explanation, or do I need to go by it again? Okay, everyone got it now. So that's why it says 16,000 instead of 5. So it's not like your code was wrong, but it is showing you exactly. So one more time. When you hear me, please give a thumbs up if you can hear me. Give a thumbs up if you can hear me. Okay. Sorry about that. I was trying to press the Control L button, and I usually used to clear my terminal, and that's where I exit the call mistakenly. So when you write LSL, notice the output. Here's what it looks like. And how many can we count here? Even though there are 1, 2, 3, 4, 5, there are 5 files. Even though there are 5 files, there's an extra line here that gives you the summary of everything here. Gives you the summary of everything that's here. So what are you doing? What are you doing in this case? It is, so this is the summary. So it counts the WC minus L, counts every single thing as a line. It counts line 1, line 2, line 3, line 4, line 5, and line 6. It counts the 6, but because my code already stated something in the lines of there are dash files in this directory, it counts 6 lines. So I just put it there. There are 6 lines in this directory. So that's why. So it's not that the code is wrong. It's the fact that it counted the summary additionally as a line, and we call it a file. So I don't know if that makes sense now. So let's see if we could do something else again. Let me see. So in this case, what if this thing here? Okay, let's go somewhere. Let's see. Let's say we have like a long list of scripts, I have something different, but let me find it. I'm trying to find. I have scripts everywhere, but I have scripts I want to use in my head, but it doesn't make sense. But let's see what's going to happen. While we listing, let's just take for instance, this was a super as long, a very, very long script. Let's say 100, or let's say hundreds of lines. There's one code that helps us. So you can track what's happening. You can say echo, this is what's happening here. Start of the script. Don't mind me, don't mind off this script. I'm going to come here and say, let's just imagine, because this one like best part. Let's just imagine echo the if block. Let's go into something like echo the file count variable. Let's come here and say, something like voila, basically. So if we were to list this again, I didn't put my name, but it listed say something like start of the script, the if block. So you see where it got tricky. It's executed here, everything went well. It's executed before the if block, everything went well. But when you enter the if block, we got the error. Does it make sense now? That's one of the ways you can debug. So if you have hundreds of scripts, that is a very, 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 very terrible experience. You cannot do this for every single line, or for every single thing you're trying to do. Unless you go back and say something like Gideon. You say start of the block, the if block, hello Gideon, the file count variable. Voila, there are 67. But that's not proper debugging. This is not cool debugging. So if I had to go back now and write something like and say, let's go instead of this, let's comment these things out. Sure. So instead of this, let's say let's comment these guys out. and write something instead of set X. So if you come here and do this again, if you see it is running this, set X is the debugging mode. Echo, you don't enter your name. It echoes, you don't enter your name. And it executes one. So every single line you see, it's going to say, this is what's executing right now. This was executing right now, and executed this, and this was executing finally before it left out. So that's what set X does. It's in debugging mode. It shows you each example of what's happening, of what happened on each line. So if you go back now and say Gideon, it's going to show this is what it did. This, it did this, did this, it did this, it did this. So this is like a breakdown of every single thing in the script, of every single what was it called again? Of every single, it's like a debugging. So it just goes, it's not trying to show you, it's really like every single step that you took, every single decision, basically. So here's it. So set X was the addition. We commented out all the echoes. So echoing each part to know where you are now in the script is not a good practice. Because if you have like a script going 100 lines or 90 something lines or 150 lines, 200 lines, this you cannot tend to do this all. Or if you use set X, it puts everything in debugging mode and just goes on and on like that. So if I did not say let's see, let's do something cool. Let's do something cool. Let's look for trouble. I don't know what this is. You see, command not found. It's an error, but it still ran. So if it still ran, yes, it still ran. But that's like the bad. So plus and plus plus, it only signifies what it's currently doing. If I am to add listing, what is it doing now? It is what? It is doing, it is coming here and executing this part. It's executing this part. This is a function. So it most likely did not even know the function because nothing is being executed here in this function block. Then if this testing, this conditional, it's executing it now. That's why you see this here. Now it's executing the greet Gideon, greet the person. So it's executing this twice because it's executing this hello Gideon and this executing both the function and this line together. That's actually 2++. Then and all that stuff. So it's like when you are combinations of what's it called again? That's the best way I can explain right now. When there are combinations of or things that are grabbed or put together, it shows like two pluses. Nothing really. It's nothing you should be scared or worry about. When it shows 1+, it's just one thing is running, or it's one thing that is taking note of, or that's simple. So set X notifies or it notes every single step you take. So it notes, oh, this is the first command. This is the first thing I wrote. It's reading this as a command. I don't know what this is. And it says, oh, cool stuff. This is the command. Let me execute it. But it turns out that the command was trash and it's not cool. And it says, oh, command not found. It just moves on again and starts executing the rest. There are some cases where this portion is a prerequisite. This portion is a prerequisite for this one to run. If that does not run, the next one will not run as you want it to run. Let's just say, let's just say this is a prerequisite. This is like a building block foundation. If this part does not run well, it means this part will not run well. That's what this would mean in this case. So instead, you don't want it to just run away and continue and just go on like that. You may not get the results that you want or desired results. So instead, you could go back and try to edit it and use something they call set E. So what does set E do? So set E, yes, sorry. Set E, it exits when there's an error. That's set E. That's the guy. Like guide us. It doesn't even wait around. So when there's an error, it just exits. So come here back and say try to exit straight up. So it exits when there is what's it called again, an error. So that was set E does. So you notice set X executes set E itself. It executes this line, and because this line there is no command, the command is not known. It's an error. Set E now trigger set E that exits the script. That's what set E does. So this is something that you can use in your code to just get to checkmate yourself when you are trying to get anything done. Also, there's a third one that's called let me see, set O pipe fill. So what does this one do here? This one ensures that every single thing, let's say this one, in this case, let's say in this case, sorry, exit. In this case, if you have to run this now, there may be an error. Let's come here and do something like, let's just put something inside. Let's just put something inside. Say, I don't. So let's come here. This I don't know what we are doing. It's not an error. It's if I leave this alone, it's going to exit. But if I put a pipe to it and say something like PS, is it going to run? Let's see. Let's see what's going to happen this time around. Sorry, let's go back. Do you know why this thing worked this way? It worked this way because let me go back and show you two things. Sorry, let me show you two things. Let me comment out this pipe fill. So it's same thing again. Let me comment out this pipe fill so you see what I'm trying to do. So far so good. Listen. Set E shows each step in debug mode, shows each step you take in your code. Set X, sorry, set E exits when there's an error. But there are some errors that set E cannot catch, especially the ones that include piping. Like when something that was piped into it, like it's used as an input for another command. So if I had to run it now, it's still going to run as cool. Understand? It runs as is. Set E is an error, yes. Set E is supposed to act on it. But why is it not acting on it? It's because its reach is limited to just commands that are not, that are not attached to pipes. So because it's attached to pipes now, it sees that it runs now. Let's just forget about it. So if you were to catch those kind of things, you would have to use set O pipe fill. So in case that there's a pipe fill, it's going to work, it's going to exit. So that's like the idea. So far so good, guys. You guys understand. Do you guys understand? You leave a thumbs up or leave a question in the chat or something similar. Let me know where I lost you guys. So everyone understands. So I'll take it everybody understands on the call. That's how I'm going to take it. All 46 of you, I get this concept. So and let's see one more thing before we wrap it up for today. Let me see how no, I don't think that's something you should be wary of. Let's write a simple script. Let's write one simple script that says last script. Let's just call it via last. Let's just use nano this time. Nano. NAS_script.sh. Which one should we write? Which one should we write? Which one should we write? There are tons of cool things to write about. Can you guys help me? Okay, let's see. Should I write? Okay, let's see. Let's see what's going to happen. So enter the directory, the path to directory that you want to backup. And you put it here as target directory. And instead of just putting arrow, it's going to come here and put it, let's make it a prompt. Read again. Or repeat. Let's say enter the path to the storage directory where you want it to store, and call it destination directory. I'm going to come now here and say, let's just call it something. Let's use if command now. Let's just check something. If any of these things, if this is not a target. So now, remember that time we use. So guys, remember the time we used, let me see. So remember the time we used, what do they call this? Z. You remember the time we used Z. So Z in that case was to check if the argument was empty. In this case, what this is doing is checking if this is not a directory. If an F that was here, if this is not a file. But I'm trying to check if this is not a directory. If the path to the directory I entered does not exist. If any of the thing, it means both of them have to be true. It means both of them have to be true, or something like that. So it says if any of them has this, same thing. Directory and something similar. Let's do something similar. Oh yeah. So you're checking both of them. Then what should you do? Then echo please provide a path to provide valid directories. That's going to tell you. Then it is most likely that these directories do not likely they do not exist. So that's what it means. Then you can exit and see. Exit one. And you close it. Then you could also do something, say, let's see, interpret this. Good. Let's add to that. So let's just call it the date. Okay, let's call it the date and move on to something else and says, oh, cool. We are backing up the directories that you mentioned, and you put it here. Oh, my pieces are going to go. Mentioned and say something in the sense of directory mentioned. Of to let's see this down. Let's call it this. So how do we do this? How do we add that? That targeting this to this. So cool stuff. So one of the reasons you may want to use VS Code is so that you would know if these things are well what's the word now? If the variables are well defined up throughout, that's something you want to check out for. But other than that, let's try a few more of this. So you could say something like, oh, backup is equals to backup. Add the name of the file to it. What's the date? Already date, then call it tar or GZ. So GZ is the GZ. That's what it's used to. You have to name your files when compressing your files or compressing your files. So that's like the idea. As in the GZ. Then let's just do that. So what should I call it again? What should I call it? Okay. Let's call it CV or CZVF and say what do you want to back up? What do you want to back up? The backup file name, that's this one. And the things we want to back up, the things we want to back up the target. Yes, hopefully it works out, guys. Hopefully it works out. Let's see. target directory. And echo on. So we want to exit when there's failure, right? So let's exit when there's a failure. So let's set O. Also it's E, yes, set E when there's a failure. There are no pipes here, so we don't need them. But it all depends on you. So let's see. Yes, exit. chmod plus X as so let's see what's going to happen. Last script. So we don't even know what we're going to enter yet. It's most likely they did not exist. So what today's date? Let's create a directory, fancy directory. And let's go into fancy directory and let's go into fancy directory and create 1, 2, 3, 1, okay, 4, 5, 6, 7, 8, 9. So we have created files called 1, 2, 3, 4, 5, 6, 7, 8, 9. So we exit again. We've come here. So what's PW? What's our parent working directory? The scripting up until here. So let's see what's this date. What's this one to put? Let's put October 2. Let's put October 2 or 2 October. Let's put it. Let's see what's going to happen. Last script is actually the part I want to back up. Insert. I want to back up fancy directory. Fancy directory. Insert here's today's date, 2nd of October. So it says we are moving up. Exactly. It has created it. So if we go here now, we see that we have a new folder, a new something is backed up, but we didn't get something right. We didn't get the date right. That's something we would always look at for ourselves. But it backed up this directory and put it here based on what we've written. So do you guys have any questions? I see that you guys are not asking any questions while I was typing away or something like that. But do you guys have any questions, please? This is how we end. Do you guys have any questions? Give a thumbs up if you understand. If you don't, ask questions in the chat box in chat section before we wrap it up. Okay, peace understands. Who else understands again? Who else understands? So that's the script. So this is the script, yes. So here's what it does. You enter the directory you want to back up. You enter the path to the storage directory where you want to store the directory, where you want to store the backup now. Enter today's date. I'm starting the date. So let's go. Then you say if what we enter as the directory we want to back up, if it's not a directory, if any of them are a directory, because you just need one of them to be true, to be false. If this one is false, it's not going to run. If this one is false and this one is true, it's not going to run. If both of them are false, it's not going to run. That kind of thing. It says, please provide valid directories. So that's the idea. So if you check either of them are directory, I told you before, we use Z to check if what we are checking is 0. If there's 0 character in the argument for an variable, there's 0 character in a variable. If there are 0 characters in a file, all that stuff, that's what Z stands for. D is to check if it's a directory. F is checking if it's a file, and so forth. So that kind of thing. So I'm checking is if this is not a directory, then echo this. You can switch it out and say something like, if this is a directory, if both of them are directory, then go forward. If this and this directory, then only then you can go forward. If either of them are not directory, don't go forward. So that's another way of tweaking the script in your own way. Then I say, cool, let's echo, we are backing up target directory to this directory, this target directory to this directory. I think it shows here. We're backing up this directory to this directory. So now you see that it's now we call this the backup name a what? Backup. The date we are supposed to put a dollar here, so it takes up in our input, but we forgot to do that. Don't mind me. Human error. Backup the date we entered, then the tab.gz extension. So it shows that this was the dates that we backed it up. So you can arrange them based on the days that you back them up, all that stuff. Then this is how you tend to back up or compress. So tar, C is from compress, Z is for zip, V is to make it verbose. Verbose is that it's saying whatever it's doing. It is compressing this, and all that stuff. So that was V for verbose. Then first the F for the file name. So the file name is this. Then what you want to compress is this. When it was done, it says echo done. So boom. So sometimes, as you can find here, this is not cool because you are seeing everything as white and black, white and black, white and black. You may want to do something a little bit cooler just before we end anything there. Do I think we should go there? We want to make everything cooler. Let's go somewhere. I think I have this installed somewhere. A green echo. Let's go somewhere. So VI last. So let's come here and set something like this nature. Insert. So red echo 31 to the 12. So this is just if you can go online and search for it. This is just like a function just to color things in red. That's the idea. So instead of seeing stuff like it, red echo. And we'll come here and exit by 1. So good. So green echo. We're backing up this. So this. Come here and say, oh, let's put $1 here. And now that we are done, we want to see something like green echo. So what I'm trying to do is, if there's an error, show me red echo. Make it red. If there's something that is cool, just make it green. That's the idea. So I'll be able to distinguish certain things from certain things. So let's come here and go back. Let's go back. Let's see what's going to happen. So hopefully we didn't mess anything up. Enter the name to no. Let's script in. Want to back up your last fancy directory. Want to start here 2nd of October. So you see what I was talking about. It's push out, it echoes this in green and this in green. So this way you're able to distinguish normal output from your output that you call out success. Same way, if you're going to do this without pushing everything out. It's going to show you, please provide the directories. It's most likely they do not exist. It shows it echoes in red. So that's how you can also improve statement progress. So this is one of the ways you could also improve your shell scripts. So does this make sense? And that brings me to this class. I don't know if you have any questions. Do you have any questions you want to ask? Do you need any clarification? Everything looks good so far from everybody. So everyone says cool stuff. So thank you for having me. Oga, can you hear me?